Hey guys, welcome back. We're going to be predicting medical costs. We're going to build 3 different models and we're going to use the most accurate one to predict the input. Anyways, guys, let's get started. Go to this GitHub where I'm going to leave a link to. Download it, upload it into your Colab or Jupyter. And let's get started, guys. Import NumPy as MP, pandas as PD. From sklearn.model selection, import test train split. sklearn.preprocessing, import minimax scaler. One hot encoder, label encoder. You can use either one. Simple imputer and standard scaler. Those libraries from scikit-learn. Okay, read it with pandas. LE equals label encoder. Fit transform as type string or else continue. Because we got to encode this data frame. Remember, guys, we got to turn these into numbers so the algorithm can work. df fill in A 0 to fill all nons. X equals everything but charges on an axis of 1. Y equals charges. SNS set style white grid. X equals Y equals charges. Data equals df1. SC equals minimax scaler. X train, Y train split, 25%. X train equals SC fit transform X train. X test equals S tree transform X test. Adaboost regressor. This is an out of the bag regressor as well as classifier, but in this case it's a regressor. Okay, model fit X train, Y train. Remember, we got to cross-validate X test, and then we got to plot the predicted line. This is the predicted line right here. Plot Y-pred, the R2 score. It's going to show it down here. 75%, it's actually the highest. I'll just give that one away. As you can see, this is the predictions based on the algorithm exploring the data. Okay, X train, Y train split. 25%. You guys can change that parameter if you want. Let's scale it. And then the random Forrest regressor. Okay. And then let's plot it after we build it, predict it. And 72%. X train, X test, Y train, Y test train split, X, Y, 25%. Fit transform X train. And now linear regression. Now guys, one more thing. Linear regression did not score the highest, even though there was somewhat of a linear relationship, as you can see right here. When we plotted it, remember? X equals BMI, Y equals charges. Charges was the target. It had somewhat of a linear relationship. However, guys, feel free to check out my other video for linear regression, for improving it by changing the polynomial degree. I will leave a link to it, just like I'll leave a link to the GitHub as well. Okay. Okay, model 2 equals linear regression, fit X train, Y train. Xpred equals model predict X test. Show the predicted line. As you can see, 73%. This was not the highest. Okay. A equals compute MP array, well, NumPy for computing. 34, because remember the age 34, I'm just using my own. Let's encode it as male, so 34, 1, and 30. It's not my actually BMI, but. And then smoker, let me change that one. Let me change that one because I am a smoker. I'm just showing you guys. You see how the numbers change? Ooh, it went up. Did you guys see that? Okay, because it's trying to predict the continuous value of charges. You guys see? Okay, so MP array, this input, A equals A dot reshape one-on-one index, pred equals model predict A, print pred with the print function. As you can see, that's the input. That's the prediction. Anyways, guys, let me show you guys one more cool feature of Google Colab. If I wanted to, I could even put a title, and let's say for a client in a real world scenario, guess what? Just like that. You guys see? You guys could also save this if you ever predicted if you guys ever predicted, a new data frame of a continuous value, but this one was empty, and all this was, you could inverse transform the old data frame, merge the predictions onto the new. You guys see? So therefore, for the client, the inverse transform function. See my other videos for that one. Anyways, guys, leave a comment for that one, and if you have a comment about how to inverse transform, I'll show you. I'll show you a link to another video. And one more thing, guys, just so you know, my channel has so many videos on it. It's got so many videos, over 150. Check them all out. If you're here for something, there's something else you need. Be sure to hit like if you liked it. Subscribe if you haven't. And feel free to share. There's probably something else somebody else needs. I've got ML Ops. This is the more basic thing on my channel. I've got ML Ops, reinforcement learning. Check out all the playlists. I've even got Streamlit, AI web apps. I've got everything you can think of. Check out my whole channel. Anyways, guys, I hope you like my video. And please check it out because I've got nearly everything on my channel. If there's something else you guys are here for now, there's something else you need. And also, guys, feel free to leave some comments on ideas for new videos. It'll really help me out. And don't worry, guys, I'm not done with the channel. And if you guys have been here this whole time, I appreciate y'all. From the very beginning, especially. The further back it goes, the more I appreciate y'all. I appreciate y'all anyways. Anyways, guys, I hope you liked the video. Stay tuned. Thank you. Bye.